Hello students, how are you all? I hope everyone fine. So today we are going to discuss about the next concept in 3D geometry. It's nothing but plane. We learned in last class what do you mean by straight line, different form of equation of straight line and its problems. So today I'm going to start the new topic and important topic of 3D geometry. It's known as plane. Okay. So plane and the this board is a plane. The room will be space. The walls of the rooms are known as the planes. Floor ಆಗಿರಲಿ, roof ಆಗಿರಲಿ, walls ಆಗಿರಲಿ, everything will be known as the plane. Okay. So first we are going to learn its equations. Okay, different type of equation. Equation of a plane in normal form. In normal form. See, this is an important question. Example as it is, they will ask, okay, derive equation of the plane in normal form. Ide tara keltare. So then so we are going to derive equations of the plane. To understand exactly what I mean by plane, we should know its equations and its properties. So now I am going to discuss about the equation of the plane. Okay, consider a plane. Consider a plane. Consider a plane whose length of the perpendicular from the origin is d. See, suppose diagram ಹೀಗಿದ್ರೆ observe ಮಾಡಿ, diagram 3D geometry ಹೀಗೆ ಬರೆಯಬೇಕು. ನೆನಪಲ್ಲಿ 3 axis ಇರಬೇಕು, x axis, z axis, y axis. Okay. So I'll take the plane like this. Actually it is not the perfect diagram because maximum you can write like this only, because 2-dimensional board and 3-dimensional diagram. Okay. So let me take, okay, this one point. Actually n again ತಗೊಳ್ತೀನಿ, ಅದು ಹೀಗೆ ಬರುತ್ತೆ, actually ಹೀಗೆ ಬರುವಂತದ್ದು, but I can write only here. This is n with this length is d, length of the perpendicular from the origin to the plane, d, this chalk distance. Okay, so consider a plane whose length of the perpendicular from the origin is d. ನೆನಪಲ್ಲಿ. Okay, ಇಷ್ಟ ಅರ್ಥ ಆಯ್ತಾ? Let vector on be the normal vector to the plane from the origin. ಅಂದ್ರೆ ಏನು, ಇದು origin O ಅಂತಂದ್ರೆ ಇಲ್ಲೊಂದು ಪ್ಲೇನ್ ಇದೆ ಅಂತ ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಓಕೆ, ಆರ್ ದಿಸ್ ಬೋರ್ಡ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಸ್ ಅ ಪ್ಲೇನ್, origin ಆ ಸೆಟ್ ಬರುತ್ತೆ. This is vector perpendicular. The vector which is perpendicular to the plane is known as normal vector. ನೆನಪಲ್ಲಿ, normal vector in a plane is nothing but the vector which is perpendicular to the plane, So vector on be the normal vector to the plane from the origin. ಅರ್ಥ ಆಯ್ತಾ? Now let vector n cap be the unit normal to the plane along the vector direction of this. I am telling along the vector on, along the vector on. So n cap is already in go to unit normal ಅಂದ್ರೆ ಏನು, it is normal vector as well as magnitude is 1. ಅಂದ್ರೆ vector which is perpendicular to the plane with magnitude is equal to 1. Normal vector ಅಂದ್ರೆ ಏನು, only it is perpendicular to the plane, not magnitude is 1. Unit normal ಅಂದ್ರೆ it's a perpendicular to the plane as well as magnitude is 1. ಇಷ್ಟ ಅರ್ಥ ಆಯ್ತಾ? Therefore, see, because of this I can represent vector on. Its distance is what? D. Distance from the origin to that point is d. Direction is along n cap, so I can represent like this. Okay, vector on is equal to d into n cap. ಅರ್ಥ ಆಯ್ತಾ? Vector on is equal to d into n cap. Now as well as this is a vector on, actually this is a vector on. Okay, ಇಷ್ಟು ಗೊತ್ತಾಯ್ತಲ್ವಾ? Now observe carefully. Let P be a point on the plane, with position vector r. So let me take one point on the plane P, okay, with the position vector r. I'll join this and it will become one vector. This vector is on this plane. On will bharat, actually ಇಲ್ಲಿ ಹೊರಗೆ ಬರುತ್ತೆ, perpendicular. On will be the perpendicular. So therefore, okay, that is vector OP is equal to vector r. Did you agree with this? Vector OP is equal to vector r. Correct? And observe carefully, vector NP is perpendicular to vector OP. vector np is perpendicular to vector on. On hೀಗೆ ಬರುವಂತದ್ದು outside, coming out, it is coming out. Vector np is on the plane, so vector np is perpendicular to vector on. So therefore ಏನಾಗುತ್ತೆ vector np dot vector on is equal to 0. correct? Vector np dot vector on is equal to 0. So now what is vector np? That is vector op minus vector on dot vector on is equal to 0. correct? Vector op ಅಂದ್ರೆ ಏನು? vector r. vector on ಅಂದ್ರೆ d into n cap dot d into n cap equal to 0. correct? ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? So now take the dot product. R vector dot into n cap. So d will be multiplied outside, alva, from the property of dot product, minus d square into n cap dot n cap equal to 0. correct? So d will be cancelled. So what is remaining? Vector r dot vector n cap minus d 1 ಉಳ್ಕೊಳ್ಳುತ್ತೆ. This will be 1. Vector n dot vector n is equal to 1 equal to 0. So therefore vector r dot vector n cap equal to d. So this is known as the normal form. This is known as normal form of the plane. Normal form of the plane, and this representation, you know, vector form. This form of the equation is known as vector form already, you know, because it is in terms of vector, but this is known as the normal form of the equation of the plane. Now what is required? The Cartesian form. ಇಷ್ಟ ಅರ್ಥ ಆಯ್ತಾ? ಏನೆಲ್ಲ ತಗೊಳ್ಳೋದು? ಒಂದು length of the perpendicular from the origin, the normal vector, unit normal, then write vector on, then take a point on the plane, okay, with the position vector r, then definitely you will get two vector, they are perpendicular to each other, so their dot product is 0. You can continue like this. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? Okay, so now I am going to show you how to get the Cartesian form of the equation of the plane. Hope you understand how we got the vector form. Now I will show you how to get the Cartesian form. So just now what we got, vector r dot vector n cap equal to d. Okay, so let me take p as, okay, x comma y comma z, okay, be a point on the plane, be a point on the plane. Okay, so therefore vector r equal to ಏನಾಗುತ್ತೆ? xi plus yj plus zk. Let me take vector n cap as li plus mj plus nk. correct? We are considering, therefore vector r dot vector n cap equal to d implies ಏನಾಗುತ್ತೆ? take dot product lx plus my plus nz equal to d, and this is the Cartesian form of the normal form. This is known as Cartesian form. This is known as the Cartesian form of the normal equation. So if they ask derive equation of the plane in normal form, then you have to answer okay, up to here for 5 marks. Up to here you have to answer for 5 marks. ಅರ್ಥ ಆಯ್ತಾ? So first ಏನು, the normal vector, perpendicular distance from the origin, normal vector, unit normal, then vector on, then take the dot product between vector np and on equal to 0. You will get the vector form. Using vector form you can get the Cartesian form. Here you can observe this is a linear equation in terms of x, y, z. Any linear equation in terms of x, y, z always represent plane, equation of the plane. Got it what I am telling? So this is the important, very important derivation. Got it? Very good. Okay, the next equation of the plane, okay, we learned equation of the plane in normal form. Now another form of equation of the plane. Okay, here the given data will be equation of the plane perpendicular to a given vector, perpendicular to the plane vector will be known, and as well as the plane passes through the given point. So example ಹೇಗೆ ಕೇಳ್ತಾರೆ ಹೇಳಿದ್ರೆ derive equation of the plane perpendicular to a vector and passes through the given point. ಇದೇ ತರ ಹೆಡ್ಡಿಂಗ್ ಅಲ್ಲಿ derive ಅಂತ ಕೇಳ್ತಾರೆ, ಆನ್ಸರ್ಸ್ ಅಲ್ಲಿ ಕೊಡೋದಿಲ್ಲ ನೆನಪಲ್ಲಿ. Okay, so first we will write what I okay in terms of diagram whatever given in the data. So consider a coordinate system x, y, z axis. So now this is our plane, this line will be our plane. So what is our plane? This is our plane. Okay, consider a plane, or let consider a plane passes through a point A. This is our point, passes through, okay, with the position vector is vector A, with the position vector A, with the position vector A, and perpendicular to the normal vector, this is just a normal vector, unit normal or normal vector, because whatever the vector which is perpendicular to the plane is known as, the vector which is perpendicular to the plane is known as normal vector. So consider normal vector as vector n cap. Consider normal vector as a vector n cap. Got it? Let P of x comma y comma z be a point. In general, let P of x comma y comma z be a point on the plane with the position vector r. This last derivation allu consider madittu. So consider any point, general point with the position vector r. Artha aita? Now observe carefully. This actually will be like this, perpendicular vector. This is the one vector which is on the plane, this is a vector is on the plane, and perpendicular vector. So vector AP is perpendicular to vector n. Did you agree with me? Because vector AP is on the plane, vector AN is coming out of the plane as a perpendicular, okay? So vector AP is perpendicular to vector n. So therefore vector AP dot vector n enagbeku, vector AP dot vector n is equal to 0. So this implies vector OP minus vector OA dot vector n is equal to 0. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? ವೆಕ್ಟರ್ OP ಏನು? ವೆಕ್ಟರ್ R, ವೆಕ್ಟರ್ OA ವೆಕ್ಟರ್ A dot vector n cap equal to 0. And this will be considered as the vector form of the equation of the plane. This is known as the vector form of equation of the plane. When plane passes through a point with the position vector A and perpendicular to the vector. I'll repeat, this represents equation of the plane when plane passes through a point with the position vector. Observe carefully my finger. Passes through a point with the position vector A and perpendicular to the vector. And perpendicular to the vector, so vector R minus vector A dot n cap is equal to 0 is represent vector form of the equation of the plane. So now what is next work? Cartesian form. So now we have to obtain Cartesian form of equation of the line. Cartesian form of equation of the line. Okay, see here. So let vector R is equal to xi yj plus zk, because R represents position vector of the point which I took already x comma y comma z. So vector form of that is xi plus yj plus zk. Vector A no x1i, because I took here x1 y1 z1, x1i plus y1j plus z1k. Okay, vector n, let it be ai plus bj plus ck. Okay, now substitute vector r, vector a, vector n in vector r minus a dot vector n cap is equal to, or vector n is equal to 0. So ಏನಾಗುತ್ತೆ r minus a ಏನಾಗುತ್ತೆ x minus x1 into I plus y minus y1 into j plus z minus z1 into k. Okay, this is okay, vector r minus vector a equal to this much. Okay, now vector n already got ai plus bj plus ck. So now take the dot product between them. In bharat any dot product tegre, dot product is 0 alva. So x minus x1 into a plus b into y minus y1 plus c into z minus z1 equal to 0, and this is known as the Cartesian form. This is known as the Cartesian form of equation of the plane passes through the point x1 y1 z1 and perpendicular to the vector ai plus bj plus ck. L position ಗೊತ್ತಾಯ್ತಲ್ಲ, L ಸಿಗತ್ತೆ ಗೊತ್ತಾಯ್ತಲ್ಲ, perpendicular vector as the point. So this is the Cartesian form, and this one will be the Cartesian form or vector form of equation of the plane in for the given data. I hope you understood. You learned two derivation, very important derivation. Both are for 5 marks. Please remember that. Okay. So next form of equation of plane. See, I will just complete the first theory part. So derivations there. Ella aadmele problems tagoltene. Okay. So next form of equation of the plane is equation of the plane passing through 3 non-collinear points. Andre points will be in a triangular form. Triangular form of the non-collinear points. Okay. So equation of the plane passing through three non-collinear points. Okay, observe carefully. I'll show you how to get the derivation. Simple. How to get the equation. Consider three non-collinear points R, S, and T. Consider three non-collinear points R, S, and T. Be three non-collinear points with a position vector, vector A, B, and C respectively. So these are the 3 points. R, S, okay, T. R, S, T. Ado triangle form alide. Non-collinear points and then triangle form. R, S, T. Then these are the 3 points I consider. R, S, T. Non-collinear points. With the position vector, vector A. Okay, this is a vector B. This is a vector C. Yalla bari bekandilla diagram alli. R, S, T. 3 non-collinear points with the position vector, vector A, vector B, and vector C. Now observe carefully. Then vector R, S and RT are coplanar vectors. Andre it is on the some plane on this plane belongs to one particular plane. Vector RS and vector RT is coplanar vector. Therefore you know that vector RS cross vector RT, their cross product is always perpendicular to both. A cross B is a vector perpendicular to both vector A and vector B. Vector RS cross vector RT is a vector perpendicular to both these two. So this is belong to single plane. So this should come out of the plane. So is a perpendicular vector to the plane. Perpendicular to vector to the plane. For the given plane, vector RS cross RT will be perpendicular. So I can take this is a vector N. So therefore vector RS cross vector RT can be considered as a vector N, normal vector. Last derivation used both vector Rn. Okay. Now consider a point on the plane. Let P be a point on the plane with position vector R. I am considering here the point P be a point on the plane with the position vector R. Now observe carefully. Vector n cap is a normal vector and P is a positive vector. So from the previous derivation, what is the previous derivation? Vector R minus vector A. What is vector A? Position vector of the point. I am considering that plane passes through point R. It is passes through point R. Dot vector n is equal to 0. From the previous derivation. So that is vector R minus vector A dot n and vector RS cross RT equal to 0. Vector RS cross RT is equal to 0. Now this should be simplified. RS and hege baribodele. See vector R minus vector A dot dot bracket RS and OS minus OR. OS and position vector of S and B alva. So vector B minus vector A cross vector B vector T the position vector C. Vector C minus vector B vector A equal to 0. And this is known as vector form. This is known as vector form of the plane. Vector form of the equation of the plane. R minus A dot B minus A cross C minus A is a vector form of the equation of the plane. And in vector you studied about this. Vector A dot B cross C, what it represents? Scalar product. So Cartesian form is very easy to write. The Cartesian form, okay, very easy to write. Suppose if I take vector R, I'll write here vector R is equal to xi plus yj plus zk. This is a vector R. Vector A and x1i plus y1j plus z1k. Vector B is equal to x2i plus y2j plus z2k. Vector C is equal to x3i y3j plus z3k. Suppose if I take this, whenever you write in notebook, write here, please write here. Okay, I'm just saving the space because I want to complete, okay, within this only. So idan you will baridi. So what is the Cartesian form? What is vector A dot B cross C? Is a determinant alva. So Cartesian form will be determinant ಯಾವ ಟೈಪ್ ಆಫ್ ಡಿಟರ್ಮಿನೆಂಟ್ ಹೇಳಿ? r minus a. First row will be r minus a. r minus ಅಂದ್ರೇನು? x minus x1, y minus y1, z minus z1. a dot b cross ನೆನಪಿದೆ ಅಲ್ವಾ? Second row b minus a. b minus a. x2 minus x1, y2 minus y1, z2 minus z1. Third row c minus a. x3 minus x1, y3 minus y1, z3 minus z1. So ಈ determinant expand ಮಾಡಿದ್ರೆ you will get the Cartesian form. ಇದು ಹೇಗೆ ಬಂತು ಗೊತ್ತಾ? ವೆಕ್ಟರ್ a dot b cross c ಸ್ಕೇಲಾರ್ ಟ್ರಿಪಲ್ ಪ್ರಾಡಕ್ಟ್. ಇದನ್ನ ಇನ್ ಡೀಟೇಲ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದೆ, ನಿಮ್ಗೆ ಅರ್ಥ ಆಯ್ತಾ ಅಂತ ಅನ್ಸ್ತಿದೆ, ಎಣಿಸ್ಕೊಂಡಿದ್ದೇನೆ. x minus x1, r minus y minus y1, z minus z1 and r minus. Second row b minus a, third row c minus a. Done. So this is the Cartesian form of equation of the plane passing through three non-collinear points. Non-collinear points, and it should form a rectangle form. Artha aita? So this is also one important derivation for 5 marks. All these are very important. One, the derivation 100% keltare for 5 marks. So very important derivation, this one and the previous two. So I hope all the three derivation you understood. Equation of the form in normal form, equation of the plane in normal form, equation of the plane passing through the point perpendicular to the normal vector, and equation of the plane passing through three non-collinear points. I hope you understood. Very good. Of a plane in intercept form. Okay, the previous three derivations are equation of the plane in normal form, equation of the plane passing through a point perpendicular to the vector, and equation of the plane passes through three non-collinear points. This is the fourth one, equation of the plane in intercept form. Consider a plane equation. Consider the plane equation ax plus by plus z plus d equal to 0, where d is not equal to 0. It cannot be not equal to 0. I mean, it is not equal to 0. So consider plane equation ax plus by plus cz plus d is equal to 0, because we know this equation in the first form, normal form. Let a comma b comma c be intercepts made by the plane. Let a comma b comma c be intercept made by the plane with positive x, y and z axis, with positive x, y and z axis respectively. With positive x, y and z axis respectively. Okay, that is the plane. See, again it's a rough diagram, not the perfect one, because three diagram I am writing in a board. You can imagine like this: x axis, this is y axis, this is z axis. So like this, plane meet the coordinate axis at one particular point. So let it be, this is a, this is b, this is c. So this distance I am telling, x intercept is this distance. This distance is b. This distance is c. So what are the coordinates of a? A comma 0 comma 0. What are the coordinates of b? 0 comma b comma 0. You studied this in first PUC, okay, in straight line. So if if the given plane makes intercepts x on x, y, z axis as a, b, c, then the plane then the plane passes through three non-collinear points. Which are the three non-collinear points? Okay, a comma 0 comma 0, 0 comma b comma 0 and 0 comma 0 comma c. Alva, these are the three non-collinear points. It is in the triangle shape. Correct? Therefore, from the previous result, the equation of the plane, therefore equation of the plane in using the previous derivation, determinant is equal to 0. What is the determinant? X minus x1. X minus x1 and a, y minus y1 0 minus 0. Y minus 0 is y, z minus 0 is z. Next, x2 minus x1. X2 minus x1. X2 andre x2 is this one, 0 minus a, b minus 0, b, 0 minus 0, 0. Correct? Next, x3 minus x1, 0 minus a, 0 minus 0, 0, c minus 0, c. So to get the equation of the plane intersect form, you only have to expand this. Only have to expand this here. X minus a expansion into bc, other term is 0, minus y into yaad barat heli minus ac, next one is 0, okay, plus z into 0 minus of minus plus ab equal to 0. So it is xbc minus abc plus yac plus zab equal to 0. So xbc plus yac plus zab equal to abc. Okay, take into that side. So divide abc to both sides. We'll get x by a plus y by b plus z by c is equal to 1. See, idralli vector form and separate illa, you will get directly the Cartesian form. There is no vector form. So this is the equation. Okay, this is the intercept form. This is known as intercept form of the plane, of the equation of the plane. Then this is the intercept form of the equation of the plane. You may get the question like this: derive equation of the plane in intercept form. Then you must write this much of derivation. Illi vector form and separate agilla irodu Cartesian form, that is x by a plus y by b plus z by c is equal to 1. Idallo ello nodidag agtilla nenpilva. First piece straight line intercept form of straight line, x by a plus y by b equal to 1. Illi one part extra because there are 3 coordinate system. I hope you understood. So intercept form of the equation of the plane is x by a plus y by b plus z by c is equal to 1. And I hope you understood how I got that equation. Okay, here I use the previous derivation to get the equation of the plane. Understood? Very good. Next problem or next derivation: plane passes through the intersection of two given planes. Plane passes through intersection of two given planes. So consider two equations of the plane like this: pi 1 r1 dot n1 vector n1 cap is equal to d1, pi 2 is nothing but r2 dot n2 equal to d2 intersecting planes. So these two planes are the plane of the plane, okay, which is given in the question. Now these two planes definitely intersect because we only assume that these are the intersecting planes. So definitely when two planes intersect, where it will intersect? It will intersect at the line. So let L be the line of intersection of two planes. Let L be the line of intersection of two planes. Now consider a point on this line. Consider a point on this line with the position vector as vector t. So vector t be the position vector of the point on the line of intersection. See, that line is common to both the planes, right? That line will be common to both pi 1 and pi 2, pi 1 and pi 2. So the t must be belongs to that both planes. T must belongs to both planes. So this t satisfies these two equations. This t satisfies these two equations. And then replace r by t. T dot vector n1 cap equal to d1, vector t dot n2 is equal to d2. So this is an important term. Okay, ಇದು ಹೇಗೆ ಬಂತು ಗೊತ್ತಾಯ್ತಲ್ವಾ? So since t is a point on the line of intersection of the plane and line is common to both, so point is also common to both planes. Okay, so now consider okay, vector r dot n1 plus lambda times n2 equal to d1 plus lambda times n2 as the required equation. Definitely this is a represent the plane, nothing confusion because it is in the form of vector r dot vector n cap equal to a constant. So consider an equation, the required equation as this. Now we have to prove that this is the required equation, or this is the equation of the plane that passes through the line of intersection of the plane. To prove that this is a okay, no need to prove it is a plane equation. Definitely it's a plane equation. Only you have to prove that this is the equation of the plane that passes through this line of intersection of the planes. To prove this, you have to prove that the point which we assume which we took on the line is also belongs to this plane. If you are able to prove that this vector satisfy this equation, then job is done. If you prove this vector is satisfy this equation, what you proved, this is nothing but the plane equation passes through the line of intersection of the two planes. So I'll show you how to prove this is the equation satisfy this vector. How to check whether the point satisfies the equation or not? You are going to substitute in LHS and RHS and you are going to prove LHS equal to RHS. So ಇಲ್ಲಿ ಅದೇ ಕೆಲಸ ಇರೋದು, ಇದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ತಗೊಳ್ತೇನೆ, LHS ತಗೊಳ್ತೇನೆ, ಈ ವೆಕ್ಟರ್ ಅನ್ನು r ಇದ್ದಲ್ಲಿ ರಿಪ್ಲೇಸ್ ಮಾಡ್ತೇನೆ, then I'll show you this is nothing but the RHS here. Consider LHS, vector r dot n1 plus lambda times vector n2. Substitute r, okay, substitute r is equal to t cap, and replace r by t cap, t vector. Substitute ಮಾಡಿ t vector t dot n1 vector t dot n2, but lambda multiplied outside because of property of dot product. So this is from this two, vector t dot n1 ಅಂದ್ರೆ ಏನು d1 ಅಲ್ವಾ, vector t dot n2 ಅಂದ್ರೆ ಏನು d2, so lambda times d2. So what is this actually? RHS, d1 plus lambda times d2, RHS. So when you replace r by t, you will get LHS equal to RHS. So what it means, this is the equation satisfies the position vector, okay, position vector vector t, which is a position vector of the point on the line. So this is the equation of the plane, which already as we know, as well as this is the equation of the plane which passes through the line of intersection of the two planes. So whenever you want to find out equation of the plane passing to the line of intersection of the two planes, use this concept. This is a vector form only there, but easy to write in a Cartesian form also. Remember, this is the equation of the plane passes through the line of intersection of the two planes. Okay, now I will show you how to write this in a Cartesian form. So consider two planes, this is pi 1, this is pi 2 in Cartesian form. You know how, okay, how we can take like this. Then the equation of the plane that passes through the line of intersection of the plane is, first equation, this directly I am writing the answer, even if you substitute here you will get the same thing, but no need. So first equation plus lambda times second equation equal to 0. Okay, if you simplify this, you will get the equation of the plane in a Cartesian form also. Remember whatever we did today in our derivation part, okay, for everything you will get examples as a problems. So I will take examples as a problems after every theory part of this 3D geometry plane is over. Okay, sand theory part is the angle between the planes, angle between the plane and the line, coplanarity condition. Once everything is over, I will take, okay, all the problem from exercise to make this concept more clear. So I hope this derivation is also understood. This is a very important derivation, please remember. So both derivation which we did today or the previous 3 derivations are also very important. Understood? Thank you.